And welcome back, students. Today we get to discuss general debugging techniques. So let's build upon what we know. So in our last lesson, we used trace statements to debug our code. However, trace statements can be time-consuming and sometimes difficult. Rather than assuming the bug is occurring in one particular place, examine your program as a whole. So, for example, if the program is giving incorrect input values, you may need to test the logic behind your algorithm. Let's look at some steps here in solving. So we want to determine the precise cause and location of the bug. That's our first step that we want to take towards fixing the error. Now, we can start by testing different inputs and outputs, such as positive versus negative numbers, in order to try to localize the error. We can also use trace statements to determine the value of a variable at a given point, such as before a loop or during a loop. Then we're going to focus on code that we have recently made changes to, or code that has produced errors before. One technique for this is to block out a section of code. If you still get an error, then the bug is not in your commented code. This technique makes it easy to examine large chunks of code at a time. Here's some common errors to check for. Start by looking for these common errors, using equals equals or not equals to in comparison statements, a semicolon terminating a loop prematurely, an off by one error, Boolean comparison statements that may cause unreachable code. It's very easy to become frustrated when you're debugging and simply start guessing. And while this approach may work for the simple programs that we're doing right now, as we move into later with more complex code and more complicated programs that are going to take several hundred lines of code, it will eventually prove to be very difficult, if not impossible, to work with that larger and more complex code. Therefore, it's imperative that you understand how one small change can impact the program as a whole. So here's some sample code to be debugged. All right, here I have string s is equal to quote char c equals quote scanner kb equals new scanner system.in. I have a do system.out.println, enter a for option A, b for option B, s equals keyboard.next, s dot to lowercase, c equals s dot substring 01, while c is not equal to a or c is not equal to b. All right, so let's go ahead and look at our first step here with debugging. If we try to run the code as is, we're going to get a syntax here when the code compiles. C equals s dot substring 01 incompatible types. Found java.lang.string required char. This is because substring is going to return a value as string when we actually want to store the value in C, which is a char. Now this is a relatively easy fix. Simply change the substring method to the char at method. So it changes to C equals s dot char at 0. This will now get the character that is in the string at position 0. And you can see we've now replaced that line of code. So let's do the next debugging step. Our code still has an error in it. If we try to run it, we will be able to input values. However, the code will not stop looping if A or B are entered. We have an infinite loop. We can use trace statements to test the code. If you include these and then output the value of s, you will find that the output is not converting the text to lowercase. Fortunately, it's the easy fix. We already have the code s.to lowercase in our program, but we're not storing that value in anything. If we take a look at it right here, you can see it just says s.to lowercase. There's nothing for it to equal in there. So let's just change it to s equals s.to lowercase. Now, that string will convert it to lowercase, and that will make it a lot easier for us to use. So now you can see we've replaced the method here with char at. We have this s equals s.to lowercase. So we've made two changes to our code. However, it's not going to be quite done, so there's another step that has to be done because that infinite loop has not yet been resolved. This is because the program hasn't met this conditions exit. Now, one way we could do this is to add break statements. However, this is a quick fix at best and not a proper solution. Using breaks will only treat it, but they won't really solve the problem. We can use a Boolean, though, to test to see if C is equal to A or B. If it does, this will change the Boolean from true to false, forcing the loop to exit. Because we are using a Boolean, though, we must also change the conditions of our while loop. So here's our final sample code. You can see we've added in a Boolean called invalid key. All right. I change KB to keyboard here just because KB was a shorthand. But you can see in here, we can now have in here our if else here to test to see if it is A or B. And you can see we are flagging it to false if A or B are entered. And this is assuming invalid key is true, right, because we set it off here to be true to start. So here's your self-test questions. Number 1, add some output statements to the following code so that all variables are traced. Int n, sum equals 0, for n equals 1, n is less than 10, n plus plus. Sum equals sum plus n. System.out.put line, 1 plus 2 plus 3 plus dot dot dot, 9 plus 10 equals sum. Number 2, what kind of loop error, infinite or off by 1, is produced by the code in the previous question? That concludes your notes, folks.